All right. Today we're going to look at a few more angle relationships. Okay, I think a couple of these you may have seen before, a couple maybe not. All right, so we're just going to define these 5 relationships and start looking for examples and figuring out what these actually look like. So first, vertical angles. Okay, I think this is probably one that you have not seen before. Okay. Vertical angles. All right, we've got a definition up here. Okay, it says there are 2 non-adjacent angles formed by 2 intersecting lines. What that actually just means is angles that are right across from each other. Okay? Vertical angles are angles that are right across from each other. Okay? And we do have to be careful, okay? We have to specify angles that are right across from each other when we have intersecting lines, okay? So let me explain what I mean by that. So if I've got, before we look at this diagram, a pair of intersecting lines, okay? Angles that are right across from each other would be vertical angles. An example that would not be vertical angles is if I had something like that, okay? This is not a pair of intersecting lines. So even though these angles are right across from each other, they would not be vertical angles because this is not a pair of intersecting lines, okay? So vertical angles are angles that are right across from each other when we have intersecting lines. Now, I guess I should have just checked that one up there so I have one more line. An important property of vertical angles, okay? Vertical angles are congruent. Okay, what does congruent mean? Same size, same shape. Okay, or they have equal measures. Right? Vertical angles have the exact same measures. So in this diagram over here, there are a lot of examples of vertical angles. Somebody give me one pair of vertical angles. So how do we name angles? Okay. So to name an angle, right, we use 3. Yeah. We use 3 points, right? So if we want to talk about angle EFG, that would be this angle right here, right? And to name that, remember we're using 3 points, and the vertex always goes in the middle. So what would be an angle that's vertical to EFG here? Okay, what angle is right across from angle EFG?
JFH.
Yeah, I think it's an I, but yeah, this one right here. Okay, angle IFH. That would be an example of a pair of vertical angles. Okay, angles that are right across from each other when we have a pair of intersecting lines. Somebody give me another example.
The complete opposite side
B
of that.
and B and A.
So Kodak, you said the complete opposite, meaning these two? Is that what you were saying, or are you talking about over here? All right, so I think Lindsay was naming some of those angles. So which angle did you say?
B and D. That thing.
So BD is a ray.
That's not no angle. Why don't we go back to what you were saying?
Wait.
The opposite of that.
Okay, then A. And then.
So angle ABD.
Yeah. So then it would be B. Like I don't know how B. The lower line of B.
yeah, there's no. You're talking about this one here
Yeah.
and that one.
Is that right?
Yeah, it's hard to name that one since there aren't any points down here. But yeah, so we could say angle ABD, and then this angle. I don't know. We could put X and Y there and say XPY.
A, B, C, and E, B, and C.
So ABC and EBC. That would not be a pair of vertical angles. So ABC is this angle right here, right? And then EBC would be this angle right here that's right next to it. The vertical angle to ABC would be this one down here. It's right across from it. So that's almost there. So this one down here, I mean, there's no label down here, but we could say like EBZ. Okay, angles that are right across from each other are vertical angles. Okay? Questions on vertical? Okay, right across from each other when we have a pair of intersecting lines. Right? Adjacent angles, then, are angles that are right next to each other. Okay? Adjacent angles are angles that are right next to each other and share a side. Okay, so angles that are next to each other and share a side. So in this diagram, again, there are a ton of examples of that. Somebody give me a pair of adjacent angles.
A, B, C.
And EB,
C.
yeah, there we go. Yes. Angle ABC and EBC. Those angles are right next to each other and they share this side. They share side BC. So that would be a good example of adjacent angles. Somebody give me another example.
What about E, G, F, wait,
EFG, okay, and
G, F, H.
GFH. Perfect. They share side FG. So that would be a pair of adjacent angles.
What about
CBD and EBD.
Yep, that would work. So Gage said CBD and EBD, right? They share side BD. That would be an example of a pair of adjacent
I
angles.
got another one. I got EFI.
All right, EFI and
IFH.
IFH. Yep, that would work. That would be a pair of adjacent angles. Good. All right. So the next one. So the next one, a linear pair is a specific type of adjacent angles. Okay? A linear pair is adjacent angles that make a straight line together. Right? Okay. So linear means line, right? A pair of adjacent angles, so angles that share a side that are right next to each other that make up a straight line together. Now there is an important relationship between angles that form a linear pair. Okay? These always add to 180 degrees. Okay? Angles that form a linear pair always add to 180 degrees. So, in our diagram, give me an example of a linear pair. Okay? Adjacent angles that together make up a straight line. ABC. Say it again. And CBE. Sure. Yep. So together, we can see that those angles add up to make this straight line, ABE. Okay, JT? EFG and GFH. Yep, that would work as well. That is a pair of adjacent angles that make up a straight line together. So the key property here is that those two angles would have to add to 180. Yep. Yeah, that would work as well. EFG and IFH. Oh, wait. Did you say IFH or IFE? EFG and IFH. Yeah. That would be a pair of vertical angles. Yes, but these two angles would not be adjacent. All right, yeah, so good thought. Yeah. So the key is that these angles, when we're talking about a linear pair, would add to 180. Okay, so for example, if I told you this angle was 120 degrees, if EFG is 120, what's the measure of GFH? 60, right? They would have to add to 180. Right? The last two definitions on here, I think, are ones that you have seen before, okay, but maybe sometimes have a difficult time keeping them straight. Okay? Does anybody remember what supplementary angles are? So supplementary angles are angles that add to 180 degrees. Okay? Any pair of angles that add to 180. Special?
That's what I was over here. It's like any angle or does it have to be multiple angles?
Yeah, so generally, I guess I should specify. Generally, we say this is two angles that add to 180. All right, but they don't have to be adjacent. They don't have to be right next to each other. We're just saying any two angles that add to 180 degrees. Right, so I could draw a 100-degree angle right here, and then down here draw an 80-degree angle. Right, they're not touching. These are still supplementary angles because they add to 180. Okay. Complementary then is two angles that add to 90 degrees. Okay. Two angles that add to 90 degrees. Now, a lot of times students have a hard time keeping those straight. Okay, I've got a stupid trick for you to remember which one's which. Right? So supplementary is add to 180. Complementary is add to 90. Somebody give me a compliment.
You look so nice.
Oh, stop it. 90 degrees. Compliment, 90 degrees.
That is so
It's stupid, but you'll remember it. It's stupid enough that you'll remember it. Okay? So supplementary adds to 180. Complementary, you give somebody a compliment. Oh, stop it. 90 degrees. All right? Alright. So this, I know this is a lot to digest right now. We're talking about 5 different ideas right here. Okay? Vertical angles are angles that are right across from each other, and the key property is they are the same measure, they're congruent. Adjacent angles are just angles that are right next to each other, that share a side. A linear pair is a pair of adjacent angles that make up a straight line together. Supplementary, angles that add to 180. Complementary, angles that add to 90. Any other questions so far? All right, so let's.
What would that be? So, go back up to here.
So like in this.
Would that be D, B, E, or E, B, G?
So you said DBE
And then the C too?
and then CBD.
Yeah, that's a complementary angle.
Exactly. Right. These would be an example of complementary angles because they're two angles that add to 90 degrees. Yep. All right. Any other questions on the properties? All right, so let's jump down to the bottom then. Okay, and we are just going to try to identify these relationships in these two different diagrams. Okay, so we're going to take 5 or 10 minutes here and practice these. So, and for a lot of these, there are many correct answers. Okay, so like number 1, I'm just naming a pair of adjacent angles. Lots of correct answers. Right, we're just saying 2 angles that are right next to each other that share a side. Okay, so let's go ahead and take, I don't know, 10 minutes or so here and try these.
Probably not.
All right, let's take a look at a few of these together here.
Let's do number 8.
So number 8 is a pretty tricky one. Okay, let's save that one for last. Let's first just look at 1 through 4. Okay, there are multiple correct answers for everything in 1 through 4, I believe. So these are just sample answers. All right. So which ones of these do we want to talk about? Do we have questions on?
8.
Which of the 1 through 4 do we have questions on?
I smacked one of those.
All right. So no questions on 1 through 4. All right. How about 5 through 7? Which one's on 5 through 7 do we want to take a look at? Is everybody good on
Yeah.
on 5 through 7?
Yeah.
All right, so 8 was tricky, right? 8 is one that we haven't actually talked about yet. So this one is saying if I've got 2 complementary angles. Well, what does complementary mean?
Complementary is the angles that go to 2 angles that equal 90.
2 angles that add to 90, right? Complementary.
Wow.
So,
And U.
well, so this one is actually kind of separate from the diagram, right? It just says use the diagram for 5 through 7.
I'm ignorant.
So here, we're saying I've got 2 angles that make up a right angle together, right? I don't know exactly what they look like, but I know I've got 2 angles that add to 90 degrees. And what we're saying is the difference in their measures is 18. So I can just call one of these angles x, and then the other one x minus 18. Okay? So how could I set up an equation here to solve? If I know these 2 angles are complementary, what would an equation look like? If I call one of them x and the other one x minus 18. Almost. So I know that we're going to have 90 degrees in there somehow, right? Because they're complementary. So I want to not just set x minus 18 equal to 90, but I want to add these together and set that equal to 90. So x plus x minus 18 equals 90. All right, so then I can solve this equation, add the 18 over, 2x equals 108, divide by 2, get x equals 54. So then this angle would be 54 degrees, and x minus 18, so if I do 54 minus 18, I would get 36 degrees. Okay, it is. Now, we did not do any examples of things like that. Tomorrow, we'll take a look at problems like this. Okay, today, we just focused on identifying these relationships. So, your homework, page 51, numbers 8 through 17, is just all about identifying these different types of relationships